Hi, we are from Group 5. We're going to explain on virtual memory management on replacement algorithm, which are Fifo, OPC, and LRU. The virtual memory concept is the separation of user-logical memory from physical memory. Here, the evolution of virtual memory, page, segmented or demand paging, and the foundation for current virtual memory method. Improvement areas is needed for placement in memory and fragmentation. Virtual memory is implemented via demand paging and demand segmentation. This side is page replacement. Is executed when one of the following occur: page fault and no free frames in physical memory. Thus, page replacement algorithm is tested using reference string and number of frames. Here is policies and algorithms. Stated here, three main policies. First, Fifo, first in, first out. Second, least recently used LRU. And third, optimal page replacement OPT. First in, first out. Least recently used LRU. Third, optimal page replacement OPT.
First page replacement algorithm, first in first out, which is known as a Fifo. The longest algorithm for remove page in memory. The efficiency is not so good. More memory does not lead to better performance. How Fifo algorithm works. Basically, the first number that comes in will go out first. Here is an example. We have our reference string and our page reference is this no data. Our first reference string is 7, so 7 enter there will occur a page fault, and then 0 enter it will occur the page fault, 1 enter and will occur the page fault, and then 2 will enter to replace the 7 because 7 is the first number in our reference string. And then 0 enter, we have 0 in our data, and then it does not occur the page fault. And then the next number we enter is 3. 3 will replace the 0 number, and the next number to enter is 0. 0 will replace the number 1, and then the next number will enter is 4, and 4 will replace the 2, and then 2 will replace the number 3. So there will page occur, and then it will occur the page fault like the others that I have been explained.
LRU, least recently used. LRU remove page least recently accessed or replace the page that has not been used for longest time of period. It causes either decrease in or same number of interrupt. It's slightly better compared to Fifo. This is how LRU works. This is a reference string. We have to load 7 at frame 1, 0 frame 2, and 1 at frame 3. Now we have to load 2. 1 and 0 have recently used, so we load 2 at frame 1. 0 have been loaded. 3 we have to load at frame 3 because 2 and 0 is recently used. 0 has been loaded. 4 we have to loaded 4 at frame 1 because 0 and 3 is recently used, and we have to complete this page fault using LRU.
OPT, optimum page replacement, is an algorithm that replaces a page that will not be used for the longest period of time. This OPT is normally the best page replacement algorithm with highest efficiency and lowest page fault rate. And this is how OPT works. The reference string starts with 7, page fault occur. and 7 is loaded into the page, so that 0 and 1 are loaded. When we arrest F2, there is no space in page, so page fault occurs. Then we trace to the front of the string and found 0. Then we replace 7, which is not found, to 2. The next 0 is good. Next, the 3, we trace again and found 0 and true. Therefore, 1 is the one that is replaced by 3. The next 0 is good again. When we found 4, this way we found 2 and 3 at the front of the strings. So 0 is the one that's gonna be replaced by 4 in the page. 2 and 3 are good. And the last page fault, 0 will replace 2 with the OPT algorithm. And this is how our OPT algorithm works.
Comparison between first in first out, LRU and OPT algorithm. First in first out removes page in memory the longest. LRU removes page which recently used, while OPT replaces page that will be not used for the longest period of time. By using the same reference string, first in first out has 10 page fault, LRU has 9 page fault, while OPT has 7 page fault. The next one is the comparison in terms of efficiency. OPT works better as it has least page fault rate. First in first out is less efficient as it has highest page fault rate, which may cause thrashing. Thrashing is high paging activity which may cause by the highest of page fault occurrence.
Created using Powtoon.